This is Geometry, Section 3.1, Pairs of Lines and Angles. The first thing we do here is we define what it is to be a transversal. A transversal is a line, and it must intersect two or more lines that exist in the same plane, and it must intersect them at different points. So when we look at the image below, it asks which line is the transversal. Well, if we look at line A and follow it down, line A only touches one line at one point. If we look at line B and follow it down, we see that line B touches only one line at one point. But when we look at line C and follow it, we see line C touches line B and touches line A. So line C is the transversal. Just to continue exercising this definition and understanding how to find a transversal, this image, when we trace each line, we'll see that line A touches two different lines at two different points. So we can say that line A is a transversal. When we follow line B down, we see it touches line A and line C at two different points. So we can say line B is a transversal. And when we follow line C across, we see it touches line B and line A at two different points. So line C is a transversal. All three lines are transversals. And again, a transversal is a line that intersects two or more different lines that exist in the same plane, and it must do so at different points. So I'm just trying to emphasize this definition and apply it to the different scenarios. And here we see we have three lines again, but as we trace the lines, line A touches two different lines, line B and line C, but it touches them at one point. I need it to touch them at different points. So line A is not a transversal. Line B, as I trace it down, I see that it touches line A and line C, but it does it at one point. We need to do it at different points. So line B is not a transversal. And when we trace line C, we see that it touches line A and line B. Again, it does it at one point, but we need it to do it at different points. So line C is not a transversal. There are no transversals. So we've seen three different ways that the drawings can be made so that we have one transversal, many transversals, or no transversals. Once we start working with images that have transversals, different angle pairs start to show up, and we're going to classify them, and we're going to spend some time investigating them throughout this chapter. The first of the angle pairs is called the corresponding angles. And it says two angles are corresponding angles when they have corresponding positions. For example, angle 2 and angle 6 are above the lines and to the right of the transversal T. So I just want to work with that a little more. Our focus should be on the intersection. So up and to the right is where they have angle 2 and angle 6. Both angles are up and to the right of the intersection, so they are corresponding in their position. I could have said up and to the left, and that would be angle 1 and angle 5. We would say angle 1 and angle 5 are corresponding because they're both up and to the left from the intersection points. We could have said down and to the left, or we could have said down and to the right. So the focus on corresponding angles is the position in relation to the intersection point. So again, the emphasis on corresponding angles is position. The next angle pair we have is the alternate interior angle pair. And it says two angles are alternate interior when they lie between the two lines which are not the transversal, and on the opposite sides of the line that is the transversal. So just to highlight these lines, we see that these two lines are not the transversal. So if you're in between them, you're in the interior. If you're not in between them, then you're in the exterior. So let's spend a little more time on that concept. We always want to identify the transversal first. So we find the two intersection points that are at different locations, and we should be able to say this is our transversal. Once you identify the transversal, the two lines that are not transversals create regions known as interior and exterior regions. The interior region is between the two lines, which are not the transversals. But the exterior region is outside of those two lines, which are not the transversal. So when we talk about alternate interior angles, that means they must switch which side of the transversal they're on, they're alternating sides, and they must alternate which non-transversal they're next to. So I can put an angle 1 up here and an angle 2 down here and say those two are alternate interior. They alternate which side of the transversal they're on and which line that is not a transversal that they're next to. And I can also say angle 3 and angle 4 are alternate interior angles because they're in the interior region. They switch which side of the transversal they're on, so they're alternating, and they switch which non-transversal they're next to, they're alternating. So now we see that I've drawn this a little bit differently, but we still can identify our transversal first. That should always be our initial step. And once we identify our transversal, we should be able to identify interior and exterior regions. And the next angle pair we're looking at is the alternate exterior angles. So it needs to alternate which exterior region it's in, but it also needs to switch which side of the transversal it is on. So angle 1 is above the transversal, angle 2 is below the transversal. Angle 1 is in the left exterior region, angle 2 is in the right exterior region. So it's alternating which exterior region, but it's also alternating above and below the transversal. I can draw another pair of angles that I call 3 and 4, and notice that 3 is on the left exterior region and 4 is on the right exterior region. It's alternating which exterior region it's in. Notice 3 is below the transversal and 4 is above the transversal. It's alternating which side of the transversal it is on. So we have another drawing. Identify your transversal first. We have our intersection points. And this time we're looking at something called consecutive interior angles. Consecutive interior angles are also called same side interior angles. Two different names, the same exact angle pair. I like this second one better. I think it makes it easier to identify it. We're going to stay on the same side of the transversal. So if I put an angle 1 here and an angle 2 here, they're on the same side of the transversal and they are both in the interior region. I can put an angle 3 and an angle 4. They're both on the same side and they're both in the interior region. So same side interior angles do not alternate which side of the transversal they're on, and they both are in the interior region. So the names of the angle pairs are very descriptive. We just have to find the transversal first, understand where our interior and exterior regions are, and once we have the transversal, our intersection points, and our interior and exterior regions, the name of the angle pair as being alternating or same side will tell us which side of the transversal the angles must be on. When descriptive words like alternating versus same side are used, then we know that we have to look for angle pairs that either switch which side of the transversal they're on or stay on the same side of the transversal. And the corresponding angle pair is about position, and is about position of the intersection. So those are all of the clues and hints we have to look for when classifying these angle pairs. So here we have some practice. Identify all pairs of angles of the given type. So A is asking for corresponding. So we find the intersection, and number 1 is in the top left. Find the other intersection and go top left, and we say angle 1 and angle 5 are corresponding. Let's look for a different angle. 2 is top right from the intersection. So find the other section, go top right, and you can say angle 2 and angle 6. 3 is down and to the left from the intersection. Find the other intersection, go down and to the left, and you get angle 7. And our last pair, we start at our intersection, go down and to the right, find the other intersection, go down and to the right, angle 4 and angle 8. B is asking for alternate interior angle pairs. So we find our intersection. This is our transversal. Here is our interior region. So find something that switches which side of the transversal it's on and is both in the interior, and we see angle 2 and angle 7. Find a different pair that switch the side of the transversal they're on and both exist in the interior, and we find angle 4 and angle 5. C is asking for alternate exterior angles. So once again, we find the intersection, identify our transversal, and we label our regions interior and exterior. So we find an angle in the exterior, and we find another angle in the exterior, but switches which side of the transversal it's on, and we see angle 1 and angle 8 are an alternate exterior pair. And we'll do this again. We take a different exterior angle, let's say angle 3. Let's choose an angle from the other exterior region, but on the other side of the transversal, and that's angle 6. And the last classification is the consecutive interior angle pair, also known as same side interior. Again, we start by saying, where are my intersection points? Which line causes both intersection points? That is my transversal. It is touching 2 lines at 2 different places. Let's label my regions as interior and exterior. And we want same side interior. So 2 and 5 are on the same side of the transversal and both in the interior region. And we look for two different angles that are in the interior region and stay on the same side of the transversal, and that is angle 4 and angle 7. So there we've gone through using our definition of a transversal, identifying interior and exterior regions, and the definitions of the angle pairs so we can identify them. So classify each of the following. How would you classify example 1? Well, we find their intersection points. We see this is the transversal. We don't have two angles that are both in the interior or both in the exterior. So we don't have an interior or exterior pair. And the only other type of pair that I can think of is corresponding. So I want to check from my intersection, angle 1 is up and to the left. From the other intersection, angle 5 is up and to the left. That means they are corresponding because they are in the same position as related to the intersection. And the first clue that led me to look for corresponding was that one angle was in the exterior region and one angle was in the interior region. So I just went one step further and said, are they in the same position? Yes, they are. So corresponding. As we go to example 2, we find the intersection points. We see which line is our transversal. And I notice that both angles are in the exterior region. They're outside of the two non-transversals. And they switch which side of the transversal they are on. So I will call these alternate exterior angles. Example 3, I locate my two intersection points. I highlight my transversal. I see that both angles are in the interior region. Now, do they stay on the same side of the transversal, or do they alternate which side of the transversal they're on? I see they are alternating, so this is an alternate interior pair of angles. So that was identifying angle pairs that were given to us, and it requires a little more analysis. So in the last type of problems that we will see, we have to classify an angle pair and name their transversal. So let's find angle 9 and angle 11, 9 and 11. And we want to find the intersection by both of those angles. And we say which line goes through both of those. That line will be our transversal. And now that we've identified our transversal, I can say that these two lines are the non-transversal and create the interior and exterior regions. Well, I see I have one interior angle and one exterior angle. That leads me to believe that these will probably be corresponding. Let's double check. So we look at the intersection and I say that 11 is up and to the left from the intersection. Let me find the intersection by 9, and 9 is up and to the left. Since they are in the same position, I will call them corresponding angles. And my transversal was line D. So pause the video here, try this next one on your own. After you get your answer, unpause and see if you did it correctly. So we're going to classify angle 8 and angle 10. 8 and 10. Now that I've located them both, I say what is the closest intersection to 8 and what is the closest intersection to 10. The line that passes through both of those, that will be my transversal. The other two lines will be my non-transversals. My non-transversals give me an interior region and exterior region. I see that both of these angles are in the interior region. And I see that they switch which side of the transversal they are on. They are not on the same side, they are on alternate sides, and they are in the interior region. So we will call these alternate interior angles. And the transversal we identified as line A. Once again, pause the video here, see if you can answer the question, and then unpause it when you're ready to check your work. So now we're going to classify angle 2 and angle 3. So let's mark those two angles. We identify the intersection closest to each angle, and we say what line passes through both of those intersections. Well, that is line C. That is our transversal. And then the other two lines involved in the intersections will create our interior and exterior regions. And I see that both of these angles are in the interior region, and they don't switch which side of the transversal they're on. They do not alternate. They are on the same side. So you can call this same side interior angles, or the other name is consecutive interior angles. And we've identified the transversal as line C. Here's our last practice problem. Pause the video, answer it, and then unpause when you're ready to check your work. We begin by marking the two angles, angle 4 and angle 14. Find the intersection next to each angle. Highlight the line that passes through those two intersection points, and that will be our transversal. Now, highlight the lines that create the intersections at the 2 points that are not the transversals, and that will tell us our regions, interior, and we have an exterior above and an exterior below. Notice that both of these angles are in exterior regions. Notice they switch which exterior region they're on, and they switch which side of the transversal they're on. So they're alternating and they're exterior. Alternate exterior angles. And we've identified the transversal as line B. Okay, so that's the end of this lecture. You can go back and rewatch the video. Use the guided note pack as you go through it to mark up any questions you might have when we meet next time in class.